All right, guys, we're in chapter 10 now. We're going to do two sections in chapter 10. We're going to do 10.4 right now, which is going to be talking about area and circumference. So a little bit of geometry, and then we're going to throw some conversions in there as we're doing it. So let's first talk about the area of a rectangle and a square. So we have a rectangle, we have length times width to find the area. Remember we talked about areas, kind of the stuff on the inside. So we can find the area of any rectangle by doing length times width. If we have a square is a little bit different than a rectangle. Actually, a square is a rectangle, just a rectangle with 4 equal sides. And so if these two sides are the same, if I call them both S and I find the area of this square, I'm really doing S times S, or can I say S squared? So the area of a square can be said specifically S squared, or you can still do length times width and you would still get the same answer, okay? Let's do a couple of problems here with the idea of area of a rectangle or a square. In this first one, it says you decide to cover the path shown in bricks. Find the area of the path, because eventually you're going to need to know how many bricks you need to do to put on the path, right? And so this isn't quite a rectangle though. It looks like to me this is a composite figure where you have a couple rectangles in one. So what you can do if you're trying to find the area of this is actually break it up into a couple different rectangles, find the area of each rectangle, and then just add them together, because then the area would just be the total of the areas. And so, I don't know, I will do this rectangle, and then I'll do this rectangle. I'll find the area of each, and then I'll add them together. So for each rectangle, we've got to find the length and the width. And so this one has a width of 3 and a length of, be careful, this is 13 plus this much, which is 3. And so the length here is 16 feet. And so really to find the area of that rectangle, we need to do 16 times 3, which is 48 square feet. We're going to do the other rectangle, and so the length of this one is 6, the width is 3, and so the area of that little rectangle is 3 times 6, or 18 square feet. So if the area of the one rectangle is 48, the area of the other rectangle is 18 square feet, we can then find the area of the whole entire thing, right, all of the bricks combined, by simply adding them together. So 48 square feet plus 18 square feet is a total of 66 square feet of area. And so then you would have to figure out how big each brick is, so you can kind of estimate how many bricks you would need to lay down. So you're not buying too much and you're not buying too little, right? All right, look at example 2. Example 2 says, what will it cost to carpet a rectangular floor measuring 12 feet by 15 feet if the carpet costs $18.50 per square yard? All right, well, I don't know about you. The first thing I do is I kind of try to visualize what's happening. I have a rectangular room. I have dimensions of 12 by 15. The first thing I need to figure out is what we're doing here. Well, it says here we're going to carpet the room, right? So we're going to put carpet all the way throughout. To me, this says I'm doing area, right? I want to find the area of this room. So this is a rectangular room. I can find the area of this room by doing my length times width, so 15 times 12. And so I end up getting an area of 180 square feet. Now the problem is we just found the area in square feet, but the carpet unfortunately is only sold in square yards. So what we have to do now is figure out how to convert those square feet into square yards. So let's do one of our conversions from chapter 9. Let's start with 180 square feet. Let's get out of square feet and into square yards. So using our dimensional analysis, let's put the squared feet on the bottom and the square yards on the top. And now we've got to figure out what numbers go in there. I need you to use your formula sheet. I need you to figure out what numbers would go in the unit fraction of square feet to square yards. You should end up getting, for every 1 square yard, there are 9 square feet. Remember, it's squared, not regular feet to yards. So I have 1 square yard to every 9 square feet. So I can take the 180 and divide it by 9, and I end up getting actually 20 square yards that I need of carpet, right? And so if the carpet, I need 20 square yards of carpet, and it costs $18.50 per square yard, then don't I have to multiply my 20 square yards by $18.50 because I have to pay that much per yard? And so I'm going to multiply that to get a grand total of $370. So I know that it's going to cost me $370 to buy this carpet for this room. Couple of different things here. You've got area, you've got a little bit of conversion, and then you've got to convert it into dollar amount. Okay, kind of a good example of all different types of things we've been talking about and combining all of them. All right, the next idea we're going to talk about is the area of a parallelogram. A parallelogram is a four-sided figure that has two pairs of parallel sides. So a rectangle happens to also be a parallelogram. But if I were to take those sides and kind of make them crooked, they're still parallel, this would be an example of a parallelogram. I can find the area of any parallelogram just like if you were to find the area of a rectangle. The formula for area of a parallelogram is still base times height. Now you've got to be careful. Base and height, a lot of students think base always just means bottom. Not necessarily. If I were to take this parallelogram and flip it sideways, the base wouldn't necessarily be on the bottom anymore. So I always tell my students, think about base and height being the two pieces that are perpendicular to each other. They make a right angle. And so on this first one, my base would be here and my height would be here. I not want to do crooked height. I want to do regular height. So I need the base and the height to be perpendicular. On this right one, the base would be down here and the height would be this piece. So base times height. Okay? All right, let's do a quick example of finding the area there. In example number 3, it asks us to find the area of this parallelogram off to the side. Now, your book only gives you 2 dimensions, and so it's not very hard to figure out what numbers to multiply together. But if this side they gave us was 6, you can see that that's a slanted height, and I don't want that. I want to find the two pieces that are perpendicular to each other. They make a right angle. And I want to take the base and the height, not crooked height, and multiply them together. Okay, so just be careful. If it's not so obvious or if it's kind of twisted around, you still have to be able to figure out which one is the base and which one is the height. Base does not always mean bottom, so just be careful. All right, so base times height, 8 centimeters times 4 centimeters gives me an area of 32 centimeters squared for this parallelogram. So we've got the area of a square, we've got the area of a rectangle, and we have the area of a parallelogram. Make sure you know what those are, and then make sure you can also convert out of that into some other sort of unit if you need to, like we did with the carpet example.